Hello friends, in our previous video we have seen the concept of FA, which is the most important part of the theoretical computer science. So in this lecture or in this video we are going to see the first type of this FA, which is NFA. So first of all, let's see what does mean by this word non-deterministic. So let's say there is a situation where you can't define any path when you have a multiple different paths. So you can't decide where to go. So in that case, you can say it as a non-deterministic. So same in this case, non-deterministic finite automata is the FA where there is are many paths for a specific input from a current state to next state. That means you have choices for moves for the given input from current state to the next state for the given automata. Let's have an example so that we can understand the concept. Start, initial state Q0, final state Q1, next state Q2. Q0 goes to Q1 for A and Q0 goes to Q2 for A. Q0 goes to itself for B and it also goes to Q1 for B. Now Q1 goes to itself for A. So here you can see from state Q0 for input A, there are two next states which are Q1 and Q2, right? Thus, it is not determined that with the particular input where to go next, right? Therefore, it is called as a NFA. I hope you got the same concept. So, now let's understand what is NFA is. The NFA basically uses regular languages. So what does mean by this regular language? Regular languages are expressed in a regular expressions. So now question arises that what does mean by regular expressions? So regular expressions are basically used to denote the regular languages. Now let's have an example, like you have a set of vowels. So here your regular expression would be A union E union I union O union U, right? For this regular expression, your regular language would be A E I O U. I hope you got this concept. So now you can understand what does mean by regular language. So regular languages are the all languages with the finite number of words. That means any symbol for A, if belongs to set of alphabets, then it would be regular language. In our next videos, we can see the basic concepts of regular languages, regular expressions, and how to determine whether the given language is regular or not. So now let's talk about the NFA. Now, what would be the formal definition for a NFA? It would be a 5-tuple definition where M can be sigma, delta, Q0 and F. In FA, you have seen all 5 tuples, but here in case of NFA, only delta, which is a transition function, has been changed, which would be delta is Q 2 raised to Q, which is a 2 raised to q is power set of q. Getting? Okay. Let's have some examples of NFAs. First example, the NFA with alphabets 0 or 1 accepts string with 0, 1. So now let's draw the NFA for this. This is our start, Q0, Q1 and Q2, which is a final state, right? So here you can see we have a string which accepts 0, 1. So our basic NFA is 0, 1, right? Now here our NFA can ends with 0 or 1. So here you can see our NFA starts with 0 and ends with 1. This is a basic, but after that when 0 or 1, now you can loop through 0, 1, 1, 0, 1, anything. But first of all, your string should be 0, 1, right? So when we draw transition table, here goes inputs, here goes states, Q0, Q1, Q2, right? So for Q0, we go to Q1, which carries 0. Q0 carries 1, no, Q0 carries nothing for 1, that means it carries epsilon, right? Now Q1 goes to Q2 for 1 and Q1 don't carry 0, that's why we have to write here epsilon. Now Q2 carries 0 to itself and also it carries 1 to itself. So this would be our transition table. Now let's have another example. The NFA with alphabets 0 or 1 and accepts all strings of length at least 2. So let's draw NFA. Start, Q0 is the initial state, Q1, Q2. So we have a condition here, that means at least 2 symbols should be there. That means your string length should be at least 2. That means your string can start with 0 as well or 1 as well, or your string can end with 0 or 1, right? So this is your NFA. Here in our previous example, here Q0 is our initial state, that's why it is marked as arrow, and our Q2 is our final state, that's why it is marked as star, right? Done. So let's have another example. NFA with alphabets 0 or 1 which accepts string ending with 0 1, right? So here start Q0, Q1, Q2. Our Q2 is a final state, right? So our basic string is 0 1, which is ending with 0 1. So you can say that here your string ends with 0 1. So that's why you can't give loop here to Q2, because you have to compulsory end your string with 0 1, so that your string can start with anything, either 0 or 1, right? So your string would be ending with 0 1, and start of the string can be anything 0 or 1, right? Now let's have a next example. NFA with string which accepts third symbol from right end is always 0. Okay, so here you can say that your compulsory your string, that means your third symbol from right end should be always 0. So your right end should be 0 or 1. Now second symbol should be from right end 0 or 1. Now third symbol is compulsory 0, and first end can be 0 or 1, right? So let's draw the NFA Q0, Q1, Q2, Q3. Q3 would be the final state. Now here you can say that it can be 0 or 1, that means it's the right end of the string, second symbol of the string, and this one the first symbol of the third one symbol from right end, right? So here from Q0 your string can be 0 or 1. That means your string can start with 0 or 1, but your string always have the third symbol from right end 0. So guys, hope you understand the concept of NFA. So in our next video we can see the next concept, that means next type of NFA, which is NFA with epsilon production, which is ultimately the part of the FA. So till then, stay tuned. Thank you for watching the videos.